So now a brief word about tumor markers. Here's a cancer cell. So tumor markers are proteins either on the surface, like receptors on these cancer cells that are unique to them, or products that are released from the cancer cells. And they do three main things. The first of which is to help confirm a diagnosis. So if we pick them up, we know that that cancer is around. Okay? So that's what they do. The second main thing is they monitor effectiveness of therapy. So here's a chemo drug being fed to this cancer cell, and if it kills it, then the tumor burden is going to drop, and we're going to know that that drug is working. Okay? And the third and final thing is if that tumor cell pops back up and recurs, we're going to know it because the tumor marker is going to increase. All right, so that's what tumor markers do. That's the purpose that they serve. Now, we're going to discuss particular tumor markers, and we're going to do this by quizzing you which cancers are associated with it. Ready? Yay, time for another game. So, the first one is prostate-specific antigen. PSA, what do you think? What cancer is associated with? Very easy. Prostate cancer, right? Yeah, okay, that was an easy one. All right, next one. CEA, carcinoembryonic antigen. It's non-specifically associated with what? GI malignancies like colorectal, pancreatic, and gastric cancer. Okay, good. Alpha-fetoprotein. What about that one? Huh? Well, it's normally synthesized by, do you know where it's normally synthesized? The fetus, right? Wow, that's why it says feto, but it can be seen with hepatocellular carcinoma, and germ cell tumors of the testes and ovaries. Wow. What about beta-HCG? What is this basically? When do you test for this normally? For pregnancy, right? This is beta-human chorionic gonadotropin, and it's normally released by the placenta. So, what type of cancers are associated with the placenta? How about a hyatidiform mole and choriocarcinomas? So, too much placenta, when it gets out of control, that's when we see that. All right. How about the S100 antigen? When do we notice that? When we use that as a tumor marker. Melanoma and other cells that are derived from neural crest. So all the neural crest tumors, like melanomas, neural tumors, and schwannomas, are all derived from neural crest. How about alkaline phosphatase? Well, we normally see this where? What type of tissue? Bone, right? So this is elevated whenever there is increased bone degradation and turnover. Thus, we see it in metastasis. So here we see some metastasis to bone there. All these metastases are chewing up the bone and increasing the turnover of the bone cells, and that increases the amount of alkaline phosphatase around. What about this one? Tartrate-resistant acid phosphatase. Here's a mnemonic for it. Trap the hairy animal. Because we see it with hairy cell leukemia, which is a B cell neoplasm. This is hairy cell. See these hairy looking cells? Very good. All right, so now let's talk about some pathogens associated with various types of cancers. And we're going to do this in a game fashion again, because I love games. So I'm going to display an image of a type of cancer, and you're going to tell me what pathogen is known for causing it. So, ready to start? Let's go. Boom. What is this, first of all? We saw it before, hepatocellular carcinoma of the liver. What causes liver cancer? What oncogenic microbe causes liver cancer? Hepatitis B, hepatitis C. Remember, because of all that inflammation causing free radicals and DNA mutations. And actually, which one of these viruses is a DNA virus? Hepatitis B is. So this actually incorporates into the DNA, and that can cause even more mutations directly. Very good. What's this? Lymphoma of the corner of the jaw in an African endemic country. What type of cancer do you think this is? This is actually Burkitt's lymphoma. And remember we talked about this. What's the mutation with this one again? This is the MYC gene, c-MYC gene, and what translocation is involved? Chromosome 8 and 14. Sticks the MYC protein from chromosome 8 onto what gene? The heavy chain gene. Every time it makes a heavy chain, it makes a MYC protein. MYC is a nuclear transcriber, increases proliferation, boom, neoplasia. But That's not what we're asking here. What is the microbe responsible for the cause of this cancer? Epstein-Barr virus. Okay. What other types of cancers are involved? Here's another one. What else does EBV, Epstein-Barr virus, cause? It's a herpes virus. What is this cancer? What is this cell? This is a Reed-Sternberg cell. Okay. And this cancer then must be Hodgkin lymphoma. What are the CD clusters of differentiation for Hodgkin and the Reed-Sternberg cell? 15 and 30. Good. We're just simulating all kinds of neural synapses in your brain right now. All kinds of integrations are going on. It's great. It's a great review. So, and don't worry if you feel lost. Come back to this section after you've read the other ones later in the book. It'll be fun. A nice little quiz. All right, so what else is associated with EBV? It's of the nasopharynx. It is nasopharyngeal carcinoma. Very good. Okay, Epstein-Barr virus. Okay, what is going on here? This is a fungating, protruding mass from the anus of homosexual male, or it is a fungating, protruding mass from the cervix that we see here in a woman. So this is cervical carcinoma. And what is the pathogen responsible? Human papilloma virus. What are the subtypes known to be carcinogenic? 16, 18, 31, and 33 are known, and others as well. What is the vaccine against? 16 and 18 at least. Okay, and so there's this virus actually releases proteins, and they inhibit tumor suppressor genes. What tumor suppressor genes are inhibited by these viral proteins? It's E6 and E7 proteins inhibits the RB and the P53 suppressor genes. Whoa, so what do these normally do? What phases of the cell cycle do these prevent the progression of? G1 to S, right? So we lose that, then we have uncontrolled progression from G1 to S and uncontrolled DNA synthesis and proliferation of the cells. Cancer. That's bad. All right. Cannot stress that enough how important that G1 to S phase is, all right? What's this? These walaceous plaques. If you see this on an individual, what are you thinking? Consistent with, this is Kaposi's or Kaposi's sarcoma. It's caused by what herpes virus? Human herpes virus 8. Very good. And what is the underlying disease? What do you think's going on here? So, not normally do we have this human herpes virus 8 activated and causing these Kaposi sarcomas all over. So this person must be immunosuppressed. And what's the most common cause of immunosuppression? This person could be on steroids, receiving corticosteroids, or they could have HIV. They could have AIDS. Sad, sad, sad. All right, let's keep talking about AIDS in a little bit. First, let's talk about this. Gastric or duodenal ulceration that progresses into neoplasia is associated with what? What pathogen causes ulcers that can lead to cancer? Helicobacter pylori, right? Everyone knows that. And how do you treat this guy? Triple therapy, and that involves typically 2 antibiotics plus 1 proton pump inhibitor. All right. Now remember MOC-CoA, because this is a helpful mnemonic for remembering the antibiotics. And the O stands for omeprazole, which is a proton pump inhibitor. The M stands for like metronidazole, and C for clarithromycin. Okay, and the A for, I believe, amoxicillin. So, continuing on here, this is the bladder, all right? And this is actually squamous cell carcinoma of the bladder. What's the normal lining of the bladder? It's transitional epithelium, not squamous. So why do we see squamous carcinoma in a transitional epithelium? Well, what's the pathogen first of all? Schistosoma hematobium is associated with this. All right, you probably didn't know that, but let's talk about what happens here. So the normal lining is transitional. When this schistosoma parasite, when its eggs get lodged into the lining of the bladder, this actually irritates the lining so much so that the lining changes. The DNA alters and causes the epithelium to change into a stratified squamous epithelium to protect itself. So what's that called? What's that called when one adult cell type turns into another? That is metaplasia, right? Another example of metaplasia. We already saw it in Barrett's esophagus, in the esophagus, and we saw it in the trachea as well with smokers. So here's another example. Cool, right? You figured it out. So this constant irritation from the schistosoma eggs leads to metaplastic transformation and potentially squamous cell carcinoma of the bladder. Here's some schistosoma eggs that we see here. Irritating. See all these eosinophils and inflammation here. It's not a happy sight. It tries to bundle up with this squamous epithelium, but sometimes the DNA gets changed and it turns into cancer. Alright, so just as there are microbes that are known carcinogens, there are also chemicals that are known to be associated with triggering neoplasias. So we're going to run through this in a similar way as we did the oncogenic microbes. I'll display an image of a chemical and you'll tell me what cancer it's associated with. Ready? Alright, this one is known for being associated with peanut warehouses where they store peanuts. What is this microbe? It looks like this. You see these fruiting bodies. What are we talking about here? This is Aspergillus, right? Right. And what is the carcinogen? Aflatoxin B. And what type of cancer does it cause? Huh? Already talked about it before. Hepatocellular carcinoma of the liver. Good. PVC pipe. Vinyl chloride. Polyvinyl chloride. What is that associated with? Here's the compound. What type of cancer? We talked about it earlier. We did, actually. Here it is. What is this? Angiosarcoma of the liver. And there's other carcinogens that cause this as well. And the mnemonic is VAT, V-A-T. So V stands for vinyl chloride. The A stands for arsenic. And the T stands for thorotrast. So here's vinyl chloride. Here's arsenic. And here's thorotrast. VAT causes angiosarcoma of the liver. Alright, what about just arsenic by itself? What is this associated with? It's important to know. It causes all types of squamous cell carcinomas, especially, in Bangladesh, they had an outbreak of arsenic where everyone was getting squamous cell carcinoma of the skin. But not only of the skin, if you inhale this, it actually can cause squamous cell of the lung too. And why would you inhale arsenic? I don't know why anyone would inhale arsenic, but millions and millions and billions of people do, probably, because that's how many people smoke. Arsenic is in cigarettes. It's in cigarette smoke, and that's why you get squamous cell carcinomas of the lung with cigarette smoke. Very bad. Not only of the lung, you get all kinds of cancers. Smoking is the #1 cause of basically every type of death. Heart disease is associated with that, and all kinds of cancers. Squamous cell of the lung. You can even see it in this type of cancer. What does this look like? These oat cells. Small cell carcinoma of the lung. You can see it in the kidneys and renal cell carcinoma of the lung, where it gets filtered in the kidneys, and even further down the line, the bladder. Now this time, it's not squamous cell of the bladder. This is actually transitional cell cancer of the bladder, okay? So, smoking is the most common cause of cancer and death in the United States. Very commonly tested. No, smoking is bad, okay? It's not very hard to know that, but just know it. Alright, charcoal. Smoked meats and charcoal grills, especially in Japanese countries, are associated with what types of cancer? Gastric, the stomach, right? There's toxins in the charcoal that actually can cause gastric cancer, and it's especially prevalent in Japan, so know that association. The boards likes associations. Here is some asbestos fibers. What do you know about asbestos? You see those commercials all the time. If you're exposed to asbestos, you're at risk of getting... I bet you were going to say mesothelioma, weren't you? No. The most common cancer is primary lung cancer. I tricked you on that one, didn't I? You walked right into it. So mesothelioma is the second most common, actually, but the most common is primary lung cancer. Here's mesothelioma. It's the icing on a cake cancer because it looks like the lung is surrounded by frosting, icing. Alright, so if someone were to smoke and be exposed to asbestos, they have a dramatically increased or synergistic increased risk of developing cancer. And remember, most common is just primary lung cancer. They have a 90-fold increase. 90 times. So do not smoke and do not be exposed to asbestos if you can help it. Alright, very, very good. Let's keep moving on here. So, continuing with carcinogens, let's talk about chemotherapy. So, here we see a chemotherapy drug. It's dripping from an IV bottle. Let's say that someone is on chemo for Hodgkin lymphoma, alright? So they already have cancer, they have a Hodgkin lymphoma, and they're getting treated. Well, do you know that certain types of chemotherapy can actually cause you to develop other types of cancer? It's terrible, right? They're actually at risk of getting another type of cancer, and that's, they have Hodgkin, they could get non-Hodgkin. That's awful. 2 types of cancer in one patient. Terrible. So non-Hodgkin lymphomas or leukemias. And the mechanism is really the chemomeds alkylating with the DNA, inhibiting the cancer cell growth. And this can trigger, anytime, again, you mess with the DNA, you can run the risk of cancer. So what other carcinogens are associated with leukemias? Now that we're talking about leukemias, how about radiation exposure, like from a nuclear power plant? Okay, that can cause cancer, that can cause leukemia. And what else? We talked about radiation causing, remember, those hydroxyl free radicals. Know this association? Papillary carcinoma of the thyroid. We already discussed that earlier.